The day was August 5, 2011. A powerful Atlas V rocket stood tall. It waited at Cape Canaveral, Florida. Inside, the Juno spacecraft was ready. This was the start of a grand mission, a journey to the king of planets. Jupiter awaited its robotic visitor. Humanity watched with hope and great excitement. Why send a probe so far away? Jupiter is not just any planet, it is the largest in our solar system. A giant made mostly of gas. It holds clues about how everything formed, how the sun and planets came to be. Juno's quest was to find these origins, to understand our cosmic neighborhood better. The Juno spacecraft is a marvel. It spins as it travels through space. This keeps it stable on its long path. It is powered by huge solar panels, a first for a mission to distant Jupiter. Usually missions so far use nuclear power. Juno was built tough, strong and smart, ready for Jupiter's harsh, radiation-filled environment. The launch itself was a spectacle. Giant flames erupted from the rocket. A thunderous roar filled the air. Slowly, then faster it climbed, pushing against Earth's strong gravity. It soared into the deep blue sky, then into the blackness of space. Juno began its 5-year trek to Jupiter. Juno's journey to Jupiter was long. It could not fly there directly. The spacecraft needed much more speed. Reaching the outer solar system is hard. It takes a lot of energy. Engineers had a very clever plan, a plan involving our own planet Earth. This was a crucial part of the mission. In October of 2013, Juno returned. It looped back towards its homeworld. Not for a friendly visit though, it came for a special boost, a gravity assist. Think of it like a cosmic slingshot, using a planet's gravity to gain speed. This technique saves fuel and time. It is a smart way to explore space. As Juno flew past Earth, gravity took hold. Our planet's pull was strong. It tugged on the passing spacecraft. This tug accelerated Juno significantly. Its speed increased by thousands of miles per hour. This extra velocity was absolutely essential. Without it, Jupiter would remain out of reach. Science and precision made this possible. The Earth flyby did more than just speed Juno up. It was also a perfect test run. Mission controllers checked Juno's instruments. They made sure everything was working. It was like a dress rehearsal for Jupiter, calibrating its sensitive eyes and ears. Juno was now truly on its way, racing towards the colossal striped gas giant.
The date was July 4th, 2016, Independence Day in the United States. It was also a day of great anticipation. Juno had traveled for 5 long years. It was now approaching mighty Jupiter. The giant planet loomed incredibly large. At NASA's mission control, tension was high. Years of work came down to this moment. The critical maneuver was called JOI. That stands for Jupiter Orbit Insertion. This was a true make-or-break moment. Juno had to fire its main engine. For precisely 35 minutes, it burned, fighting against Jupiter's immense gravity. The goal was to slow down just enough to be captured by the planet's pull. Then came the news: success. Juno's engine performed perfectly. The spacecraft was officially captured. It had entered a long, looping polar orbit. This path was very different from past missions. It would take Juno closer to Jupiter, closer than any spacecraft before it. Cheers and relief echoed the Earth through mission control. This special orbit was key to Juno's mission. It was designed to minimize radiation exposure. Jupiter has incredibly strong radiation belts. These can damage sensitive electronics. The orbit also allowed for close flybys. Juno would skim just above the cloud tops, then it would loop far out again, ready to unveil Jupiter's deepest secrets.
For decades, Jupiter's core was a puzzle. Scientists had theories, of course. Did it have a small, dense, rocky center, like a bigger version of Earth's core? Or was it something entirely different? Juno was built to look deep inside, to finally answer this fundamental question: what lies at the heart of this gas giant? Juno didn't use a drill, of course. It used the subtle science of gravity. As Juno orbited Jupiter again and again, it measured the planet's gravitational pull. Tiny variations in gravity were detected. These changes told a detailed story, a story about what Jupiter is made of and how that material is distributed deep within. The discovery was a big surprise. Jupiter does not have a small, solid core, the kind many models had predicted. Instead, its core seems to be fuzzy, or perhaps it's better to say diluted. Heavy elements are there, but mixed. They are blended with lighter hydrogen and helium, extending out to almost half of Jupiter's radius. This changes everything, or at least a lot. It impacts our ideas about planet formation. How did Jupiter, the king, get built? Did it start with a solid core, then grab gas, or did it form more like a star? The fuzzy core suggests a complex history. Jupiter is even stranger and more wondrous than we ever imagined it to be.
Jupiter is a planet of storms. Its colorful bands are fast-moving winds. The Great Red Spot is legendary, a hurricane wider than Earth itself. It has been raging for centuries.
But Juno showed us there is so much more to Jupiter's wild weather. The views were simply breathtaking. Juno's unique polar orbit gave us a new view. It flew directly over Jupiter's poles, and there, it found something amazing.
Giant cyclones swirling like cosmic pinwheels. They were arranged in stunning geometric patterns. 8 enormous cyclones churned around the North Pole. 5 similar behemoths circled the South Pole. These were completely unexpected formations.
These polar cyclones are truly immense. Each one is thousands of kilometers across, almost as wide as the entire United States, and they are surprisingly stable systems. They seem to remain in their patterns, churning and spinning for years on end. How they form and stay this way is a new puzzle.
Jupiter's atmosphere is full of mysteries. Juno Cam, the spacecraft's visible light camera, provided many of these stunning images. It was included partly for public engagement. Citizen scientists helped process the raw data. They turned it into beautiful, useful pictures.
These images revealed clouds in 3 dimensions, showing incredible depth and complex structure, finding profound beauty in the atmospheric chaos.
Scientists knew Jupiter had lightning. Voyager and Galileo missions saw it. But Juno found something quite new. Jupiter's lightning is not like Earth's. On Earth, lightning often starts low, deep within water-rich storm clouds. But Jupiter's sparks are different, a new kind of Jovian electrical discharge. Juno's instruments detected this lightning. It seems to originate relatively high up, shallow in Jupiter's turbulent atmosphere, in regions where clouds are rich with ammonia and also with water ice. This was a curious combination indeed. It pointed to an unfamiliar process, something unique to this gas giant.
This discovery led to another clever idea. The concept of mushballs was born. These are like ammonia-rich hailstones. Water ice and ammonia gas combine. They freeze together into slushy balls. These mushballs then grow larger and heavier. Eventually they fall deep into Jupiter's atmosphere, carrying ammonia from the upper clouds downwards. This ammonia snow helps explain things. It solves a long-standing mystery. Why some parts of Jupiter's atmosphere seem to be missing a lot of ammonia, the mushballs are carrying it down, transporting it to deeper levels. This is fascinating atmospheric chemistry, a truly shocking and cool discovery.
Juno's primary mission was a great success. It revealed so much about Jupiter. So NASA decided to extend its life. There was still more science to do. Juno could do more than just study Jupiter. Its fascinating, diverse moons beckoned. These worlds hold their own secrets, waiting to be explored more closely. The giant moon Ganymede was a prime target. It is the largest moon in our solar system, bigger even than the planet Mercury. Juno performed a very close flyby. This happened in June of 2021. It was a rare and valuable opportunity to study this icy world in detail, gathering precious, close-up information.
Ganymede is unique for another reason. It has its own powerful magnetic field, the only moon known to possess one. Juno's instruments studied this magnetosphere. They also investigated Ganymede's thick ice shell and gathered more evidence for its subsurface ocean. This flyby provided crucial new data on this intriguing, potentially habitable ocean world. Juno's extended mission did not stop there. It also made close approaches to Europa, another icy moon with a hidden ocean. And it flew past fiery Io, the most volcanically active world known. These encounters greatly expanded our view of the entire complex Jovian system. It's not just a planet, it's a system of diverse worlds.
Juno is a sophisticated robotic explorer. It is packed with advanced scientific instruments. Each instrument has a very specific job. Together they see, measure, and map. This amazing spacecraft is an engineering feat designed to operate in a hostile place. Its tools unlock Jupiter's ancient secrets, allowing us to understand the giant planet. One key instrument is the microwave radiometer. The MWR has 6 different antennas. It peers deep below Jupiter's visible clouds, much deeper than any camera can see. It measures microwave radiation from the atmosphere, revealing its temperature, structure, and composition, especially the distribution of ammonia gas, unveiling the hidden workings far beneath.
The magnetometer experiment, or MAG, is vital. It precisely maps Jupiter's powerful magnetic field. This field is enormous and incredibly complex. Understanding it tells us about Jupiter's interior, where the field is generated. The gravity science experiment uses radio waves. It tracked Juno's orbit with extreme precision. This data uncovered the fuzzy, diluted core. JunoCam is the mission's color camera. It takes stunning, high-resolution photographs. Its images are important for science. They also serve a vital role in public outreach, engaging people all around the world, making everyone part of this great adventure. Students and citizen scientists contribute. Modern technology truly enables cosmic discovery.
The Juno mission has truly reshaped our view of Jupiter, the colossal king of planets, and, by extension, of planet formation itself. Its discoveries are numerous and profound, challenging old theories, sparking new ones. We thought we knew Jupiter reasonably well, but Juno showed us there was much more to learn and to be amazed by. We now see Jupiter as even more dynamic, a far more complex and surprising world, with bizarre geometric patterns of polar cyclones, with shallow lightning and ammonia hailstorms, and with a strange, fuzzy, diluted core. It is so much more than just a big ball of hydrogen and helium gas. It is a place of active, ongoing processes.
Juno's remarkable success serves as an inspiration. It encourages future missions to the outer planets, to explore Uranus and Neptune, for example. It demonstrates what humanity can achieve when we apply our intellect and curiosity, when we boldly aim for the distant stars. Juno is a testament to human ingenuity, the relentless spirit of exploration in action. The vast amounts of data Juno collected will be carefully studied by scientists for many, many years to come. New insights are still waiting to be found, hidden within those measurements and images. Juno's legacy in space exploration is secure. It stands as a magnificent triumph, unveiling cosmic wonders for all of humanity.